Hello everyone. So topic I am going to cover today is recent trends in machine learning. So basically, this is the overview diagram of recent trends. Now, machine learning has already reached manufacturing, healthcare, insurance companies, then customer service, transportation, e-commerce, and automobile. Now we will go in detail about each aspects of this, and we will see how it has been implemented in different applications. So most of you heard this Industry 4.0, Industry 4.0 multiple times, but what is it exactly? So Industry 4.0 is a smart manufacturing achieved with IoT, autonomous systems, and trained with machine learning. So if you just to summarize, brief Industry 1.0 was basically a steam engine. Industry 2.0 is mass production or assembly line, what we call conveyor belt. Industry 3.0 is basically automated production with computers like IT systems integrated with the companies. And now the smart manufacturing through the mobile or IoT device with the help of machine learning. So currently, most of the industries are following this approach. They have some manufacturing unit like this, where they place an object. There is a computer vision, like machine vision camera that takes the image. Now, these cameras could be different, like regular RGB camera, or it could be an infrared or thermal camera, or it could be the combination like a stereo imaging system, which then classifies based on the classification algorithm and send this data to the supervisor. Now, supervisor checks manually by the time the conveyor belt takes that object to the supervisor. And if the classification is correct, it marks that product as faulty or not faulty. And then recurrent learning happens. That is, it again keeps on training itself and try to achieve 100% perfection in this manufacturing. So this is what we call human decisions, where human is actually training the system. And you can imagine after maybe 1 lakh cycle, 2 lakh cycles, this human can retire himself and then machine will take over on its own. So that is the second part where we will see a complete autonomous manufacturing. Now, here is a picture of a car industry where there is no human intervention. Everything is manufactured by machines, and then everything is visualized. And if there are any defects, those cars are taken into the side conveyor belt for the repairs. And whatever is the problem or defect with that structures is also mentioned along with the part number. So this is what we call a fully autonomous manufacturing system. The second most important application of machine learning other than manufacturing industry is what we called a healthcare system. So what is there in healthcare? You have some patient data, like here you have some structured unstructured patient data. Now what is the structured data? Basically everything is in a Excel format, a single column entries. That could be a structured data. What could be the unstructured data? It could be a handwritten documents by the doctor. It could be the pictures of the patient and so on. So they are not common. They have different structures, images or Excels or CSV files and so on. And then you put it to a prediction model and then try to predict how many of the patients will have a hypoglycemia, like low sugar level, or hyperglycemia, or BP, or any other disease prediction. So based on the trends and the predictions by the doctor and previous history, this machine learning algorithm learns on its own. Now, another very important application during COVID we found out for the machine learning is to detect the COVID based on the CT scan images or a X-ray image. So basically, if you feed this X-ray image to a machine learning algorithm, the algorithm can tell you without presence of radiologist whether that fellow has a COVID-19 or not. Now, this method is preferred because currently COVID-19 is happening through RT-PCR or nozzle swab. But not all the hospitals have this RT-PCR facility, and they have to send the report outside. So, but X-ray and CT machines are typically there. At least X-ray is always there with the hospital. and they can use this technology to detect whether the person is COVID positive or not based on the X-rays or even for the CT scan. So this is the application of machine learning in the domain of the image processing for the healthcare system. Now, another interesting application of this machine learning came out for the insurance companies, and there are a lot of openings with the insurance companies for the machine learning expert. Now, remember, you get the insurance premium based on your previous claims. So, how to do that? Basically, insurance company give their all data to the machine learning software, and that software finds how this fellow is claiming its bills. So basically, healthcare companies wants that, insurance company wants that nobody should claim ever, but they see the pattern that this fellow is particularly claiming a lot of medicines, or he might be in a bad health, and then they have two options: either to reject his insurance application or to apply whenever he renews. You set a larger premium to him based on his past records. So this is where machine learning is used in a insurance companies. Now, machine learning in customer service. Now, you won't believe, most of the times whenever you call a call center, typically the call basically goes to a ML classifier. Based on type of your complaint, it decides whether to transfer that call to actual customer care executive or just to reply based on his previous decisions. So this is where the customer care service comes into the picture. Like there were too many jobs for telecallers and what we call at BPOs and so on. But nowadays, these jobs are reducing because of this computerized customer service care, or what we call as IVR, Intelligent Voice Operated Robotic Systems. So this is where the customer care service applications lies for the machine learning. Now, the next and most important application of the machine learning is basically with the CCTV footages. So, machine learning used in transportation might have this kind of videos where multiple vehicles are being passing, and it is impossible for a person to track down each and every vehicle and find out if there is anything wrong or not. So one approach is, while transportation, they can calculate the speed of the vehicles, the type of the vehicle, even the number plate recognition for the vehicles being theft or any criminal activity against that vehicle number is recorded. So these kind of applications are happening during the transportation system through your CCTV footages. And even RTO is requiring many of the machine learning engineers to process this video data. And the simple application could be, whenever they break the speed limits, you can charge him automatically. And even in Mumbai, multiple places this has been implemented. But currently there are people manually watching, and that's why you will not get every time a ticket when you overspeed, because it depends on that person's mood also. But soon this machine learning will take over, and then there is no chance that you break the law and you are not being charged. So next application is, you all must have seen something called as Google Maps, where you can put the source and destination and it shows you the fastest route or all possible alternatives. So how it happens basically, it takes the taxi car sharing data. It also takes your mobile phone's data as a GPS data, and also accelerometer and traffic volume data. So all this data is fed to the machine learning solver. Basically, it calculates the different points traffic, and based on the fastest time prediction and volume of the traffic, it gives you the best route. Now there are some demand modeling, like even if your Google map is saying take right and you take a left or you go straight, then it automatically recalculates the entire thing and gives you the next possible route, which is the best route. In some cases it say no, it's not possible, you have to take U-turn. So all this machine learning in transportation is a very good application to work on, and it is one of the most challenging applications, because obviously the data you are getting is only through your mobile phones. Now you can imagine a street where nobody is using a mobile phone and it's full of cars, then this entire algorithm will collapse. So there is a need of a satellite imaging, live satellite imaging, to give you a better results with this kind of transportation application. The next very important application, what I would say, is through the automobile industry. You must have heard that there will be a driverless car soon on the road. So how these driverless cars actually work? Basically, they have a camera, inbuilt camera, LiDAR, and a radar system mounted on them. So they take the images like this and then they classify in real time. So you can imagine the processors they are using are GPUs and not CPUs. And these GPUs are typically 128 cores or 256 cores. And your typical CPUs are like 4 cores, 8 cores. So the processing power is tremendous, and it can do the same job which your PC does in, let's say, half second. It can do it in half microseconds. So almost order of magnitude change in respect to time is there. And that is important because you don't want to miss this autonomous car, go and hit somebody. That should not happen. So that's why automobile industry has a large application. Like I said, not only camera, it also has something called as lidars and radars. So radar is basically rotates 360 and captures all the objects around it. LiDAR does the same thing. LiDAR happens with the electromagnetic waves, where LiDAR works on the laser principle. So basically, it transmits a light, and whenever it hits obstacle, it takes back that light and feed it back so that the algorithm can run, and a map is created. Now you can imagine this LiDAR radar based system. Like in previous example in camera, whenever there is a night time, it is very difficult to capture the image and process them further. There are some night vision cameras integrated, but their accuracy is not so good compared to the lidars and radars. So that's why we go for the multi-input system, where there is lidar and radar fitted to your car, and it takes all the inputs and then forms a map around it, and then it automatically decides with what speed the car should move, which lane the car should go, and so on. So obviously the previous application of smallest time to the destination still apply here also, but along with that there is a autonomous driving mechanism fitted to this. Next application is e-commerce industry. Now e-commerce industry machine learning is very common. Most of you, when you visit Flipkart or Snapdeal or Amazon, you will see whenever you search for a single product, it shows you the similar products around it, and it also shows you the recommended or frequently brought together products. So basically all these e-commerce is happening because of the machine learning. What it does, it actually calculates. Let's say you search for a 3D printer. Now in 3D printer, if you click on pursue i3 3D printer, then it increases its weight, and whenever next fellow search for 3D printer, the pursue i3 3D printer comes first, and so on. So there are some cases where they use something called as market basket analysis also. Like they know that person is looking for pursue i3 3D printer, they purposefully keep it down, and they produce the unnecessary product on top of their list which are sponsored, so that people buy those also. And that's how the market basket analysis work. Like basically in this analysis, milk and bread are frequently brought together. So what they do is put the bread in one corner of the shop and milk in the other corner of the shop, diagonally opposite, so that person who wants to buy a milk and a bread, they have to travel through the entire shop. Similar approach is followed with the e-commerce websites. Now what I have mentioned in e-commerce is something what we also see with the Netflix or your Hotstar or any other video watching platforms, where it shows videos recommended for you automatically based on your past history. It calculates certain frequency for each video, and highest frequency videos are popped up for you to watch. Similarly with the applications like where you buy the clothes, it can also shows you the clothes recommended for you or frequently brought together, and similar products. So it's a very good application, and You can imagine there are thousands of opening once you, I guess you are in second year now. So by the time you will pass out, there will be lot of openings in the recommendation system and e-commerce website and in this domain. So I would recommend you do one or two projects in this as a mini project or internship, so that you have eligibility for these kind of companies also by the time you graduate. Next is machine learning in the cell culture application. Now you might know about this biotechnological applications like drug discovery, drug delivery systems, and so on. We need something called as cell culture. So we put a drop of some culture which are having one or two bacteria and let it grow with a particular conditions. And these conditions, like what light they need, what temperature they need, what pH they need, is basically decided by this cell culture medium machine learning method. So what it does is it records when the cells are growing at fast speed, at what light, at what CO2 level, and what is the food given to those cells, and so on. And based on that, it predicts a model, a growth prediction model, and then it automatically sets those conditions. So this is how the cell culture model works for the machine learning application. Now, next is another application very important for countries like India and New Zealand, where the farming is the major business. So, crop prediction system. Now, you know, there are 2, 3 crops are being taken in a year, and which crop to plant is basically experience of the farmer. So why not put that experience into the machine learning system? And based on the temperature data, the moisture data, the soil moisture, the pH level of the soil, and the temperature, soil temperature, humidity, we can predict something like which crop you should put to earn the maximum benefits. Like yield might be different. Let's say onion is at higher price, and maybe you have wheat along with it, but the price of wheat is very low. So yield might be more with the wheat, but it can also tell farmer that if he go for onion, he can earn this much, and if he go for wheat, he can earn this much. So based on that also, it can work. So basically, this is very interesting and important application, and currently not too many industries are into this because this is a farming industry. And if you can provide such solutions like a unit, those who are interested to become an entrepreneur, it's a very good opportunity for them to go in this direction. We call them agri-tech industries, and there are very few, I guess only 20 to 12 industries in agri-tech domain which are actually working on this kind of applications. Now, next application is machine learning for food grading. Now, you might know that there are some fruits which are called export quality. Now, in typically in outside world, they grade the foods as A, B, C, D, and they keep class A, that is the highest quality grade fruit in their country. It's reverse way in India. We export the highest quality outside and keep the lowest quality for the poor people to consume. So what this grading system does is like human test this each and every tomato by hand or by looking at the color of the tomato. This kind of systems takes the images and maybe some other data like pressure or hardness of the tomato, and it can also tell you what grade that fruit is. Now, if it has something called as NIR, infrared absorption, it can also tell you how sweet that fruit will be just before cutting only. So you can get the sugar content from the fruit also. And that is very important application, because if you know like mango is not sweet now, and if you try to cut it, it won't be useful. So you can wait for it to become a sweet, or its sweetness level is decaying, so you can cut it immediately. So in either ways you are benefited because you are using the fruit at its best time. So this is another application what we call as fruit grading. Next very important application in this plant related applications is plant disease prediction. So generally you see some spots on the leaf, but you don't know what it is. So machine learning can have infinite database where you know this plant has this kind of diseases and this is how it looks. And once you just click a picture of that leaf or something, it can tell you which fertilizer should I use to avoid this plant disease, or whether this disease is deadly for my farm or not, and so on. So this is basically an application of a machine vision where you click a picture and send it to the server, and then you get the output from it. So these are the different applications in the uh, area of the plant or agriculture. The last application I would like to discuss here is in the machine learning used with the comfort systems. So you can imagine a camera is watching you and you can sleep, uh, most of you might have turned on the AC, and then after some time you start feeling cold, and when you turn it off you start feeling hot. So based on your sleeping moments, it can track down whether you are comfortably sleeping or not, and accordingly it can adjust the comfort cooling for your room. And these are the typical applications where most of the work is going on. And this is where I'm also working. So if you are interested, we can work together on these projects, and you can join as an intern also. So that's it from my lecture. I will stop recording this, and if you have any doubts you can ask me.